All right, so far we've graphed things that have a horizontal asymptote, growth and decay, right? We graphed some vertical asymptotes, that is logarithms, right? So rational functions are going to have possibly more than one asymptote, possibly horizontal and vertical. Most of today's are going to look something like, these dashed lines are asymptotes, they are not the axes. The axes could be anywhere. For instance, this could be the XY axis. I don't want you to think that that's what it is. But they'll look something like this. They'll hug the asymptote from either direction. There'll be two parts of them. They look kind of funky, okay? Now, we will get into some, and we'll save them for tomorrow, some more complex rational functions that will look all kinds of ways. But today, we're going to focus on some simple ones that look like this. What does rational mean? We know what irrational means, but what does rational mean? Okay, define irrational for me. Goes on forever. No pattern. Can't be expressed how? Okay, think about this then. When we talked about rational exponents, we were talking about what? Fractions. Fractions. Did you? I'm sorry, I didn't hear you. Say it louder. I'm sorry. Oh, I'm sorry, I didn't hear you. Okay, so we're talking about fractions. So our equations are going to look something like, this whole chapter is about big nasty fractions. I mean, too, it's one of my favorites. I hate fractions. All right. And there's actually, could be a little plus K on the end. If you look at your, I'm gonna walk you through it. If you look at your flow chart, you have a little question mark for some reason in this middle box. It should be an H. I do not know why word formula will not print an H in an equation. I just can't get it to print. I don't know. But I need it to be H. So make that an H. It's a question mark in a box, and it should be an H. See the middle box? Yeah. All right, so I think the easiest way to teach these is to just do it by example. So we will just do an example. I hope everyone can read a little flowchart graphic organizer like this. Yes. All right, so let's look at the first question. Here's my equation, -4 over x plus 2 minus 1. So the very first question at the top, does x have an exponent in the top or bottom of the fraction? An exponent on x? No, right? There's no exponent on x, the x itself. There's no exponent on the x. So that's a no. So I follow the no arrow here, right? Now, does x appear in the top and bottom of the fraction? No, it's only in the bottom, right? So I follow the no arrow. So I'm in this middle box right here. And that is exactly what my equation looks like, right? All right. So just quickly, if h or k are missing, they are 0. All right, so step 1, and these are steps for each form. Find and graph the horizontal asymptotes. Okay? Y equals k. That is correct. So if I go back, my horizontal asymptote is going to be y equals -1. I'm going to show you. We'll get there. We'll get there. Eager beaver. All right, horizontal asymptote check. Step 2, what does it say? Find and graph all vertical asymptotes. That's what we're fixing to do. That's step 2. So you set the vertical asymptotes, you set the denominator equal to 0, and you solve. Why might that be an asymptote there? Why would I set the bottom to 0? That's right. You can't divide by 0 So if I make the bottom 0, it's telling me what it can never happen, right? Well, asymptotes are where it never touches. So -2. You could have more than one.
Wait. I'm just waiting for them to.
If you solve it, when you solve it. Yes, yes. Because if there's an X in the top also, we wouldn't be in this box, we'd be in the first box. All right. Now the last step is to make a T-chart and plot points. And then I want at least 2 points on either side of the asymptote. Okay, now, these equations get nasty. Okay, and plugging in gets a little crazy. We're going to talk about it. 2 to the left would be 1, 2, 3, 4. So -4, -3. And 2 to the right would be -1 and 0. Now, can you do more points? Yes. You need at least enough points to pick up on the pattern. It may take more than that. It may not. But you need at least 2 on either side. 2 to the left of every vertical. So if you have 2 vertical asymptotes, then you'll have 2, 4, 6, 8 points you'll need. Okay? You can get bogged down in plugging this in. So instead of plugging this in and doing by hand, we're going to use a calculator. So take out your calculator. Graphing, yeah. This is, the asymptote is -2. So -3 and -4 are on that side of the asymptote. And -1 and 0 are on that side. 2 to the right and 2 to the left. Yeah. Because I'm only plugging in X's. Yes, yes it is. Wait till you see the one of me climbing the mountain. Okay. Mine too. It was a fun day. Okay. Remember fractions? Fractions go in parentheses, and when there's multiple parts in a fraction, you also need to put that in parentheses, okay? So you have to be very careful as you enter that. This is the hardest part, okay? Yep. All right, so I've got parentheses for the fraction, -4 divided by. Now, because that bottom's got 2 parts in it, I'm going to put a parenthesis around it. X, what was it, +2? I'm going to close the bottom, and then I close the whole fraction. Okay. All right, we're not actually, I mean, you can graph if you want to, but we're more interested, since we're graphing by hand, in finding the values. Okay. Is everybody with me? Yeah.
Is there a way you can take your calculator and, like, say this is
Math, enter.
Hold up, don't. You go like this. Don't actually press the button.
When you're in the main screen and you get a decimal, is that what you're talking about? You hit math, enter, because the first option under math is fraction. It may be an irrational number that can't be changed into a fraction. All right, now, I'm not going to actually graph on this because I'm going to graph by hand. What I want to do is utilize the table function. Okay, so this is something we haven't done yet, but it's a really handy tool. All right, if you hit second graph for the table, it's a big T-chart is what it is. They've already been plugged in for you and the Y's are already there. Second graph. Several of you have said your table doesn't look like this, and I'm going to change the way mine looks. I just wanted you to see where we got to get it. If you look over the window button, second table set, independent is my X, right? And dependent is my Y. I want to change the independent to ask, which means I don't want it to automatically tell me the X's. I want to be able to input the X's and then it tells me the Y's. So hit enter over ask. Make sure that's highlighted. So make sure your table set looks exactly like mine. It doesn't matter what that number is if it's asked. You put whatever you want. You should have ask and then auto because you want to ask it X and you want it to automatically give you Y. You want to ask the independent and automatically give you the dependent. Second window. So now go back to your table, second graph. Yeah. You should be able to type the values you want in there now. Your window range, your negative is not smaller than your, you assume 6 a standard window. All right, your parentheses, something's not, you didn't do divided by. So you just have a linear function. All right. So remember what I needed? I needed -4, -3. -2 was the asymptote, and then I needed -1 and 0. Yes. Well, you could have, but sometimes you might need like 1/2, -1/2. You might need -25 and 20. But if you would like to scroll, you can. All right, -4 is 1. What was 3? What was -3? 3, -5, and -3. And if you were to plug these x values in here and simplify, just to show you, if I did -4, well, -4 divided by -4 plus 2 is -4 over -2, which is +2 minus 1, which is 1, which is exactly what I have here. But you see how long that took me? Yeah. Plus, there's room for mistake and error, whereas if I just plug it in the calculator, I can pull the point from the table. All right, let's plot it. -4, 1. Negative, I should move all that garbage right there. All right, -4, 1. What'd you say? I got 1.
Boy, have you lost your mind?
Now, Wills. Yes. A -4? All right, check your... All right, I'm going to go ahead and connect. These have to approach the asymptote curved around from either side.
Wait, whoa. That's not what I did.
Two different, yep.
They're 2 different graphs.
It's 2 different pieces. If you look at the graph, your calculator may or may not graph asymptotes. Mine does not.
Mine does.
Okay.
Mine graphs 1. Yeah, it graphs 1.
So you have to be aware of where those are so that you can interpret your graph correctly when you do
Oh
it.
yeah, I can graph this one.
Except for the vertical line graph.
Can we do like a graph that like makes it
All right. Let's talk about the domain. So domain is X and it's left to right, correct? You look at this as a whole. You look at the graph as a whole. So I'm looking at the pink. If there's ever pink, then that's part of the graph, right? And so left to right, what's the furthest left the graph goes? -infinity. It goes up to what? But there's a hole here. There's a place where it can't be. -2. It can't be -2, so I put a parenthesis. But wait. It picks back up, right? So I put a U. It still doesn't include -2, but it does continue all the way to infinity. Remember, we talked about this briefly when we talked about interval notation. We've done it. Yeah. It's okay. Yeah, U combines them. You knew. Y'all talked about union and, well, you used to learn union and intersection of sets. But, all right, let's look at range because it works the same way. Negative infinity, and then I go up until I hit this roadblock here, which is a -1, u, and infinity. So if you ever want to leave just one value out, one value only, the back-to-back parentheses with a u between does that. Okay. Let's do another.
Please don't give us a lot.
It's really not bad. By the way, the parent graph for this, remember we talked a little bit about parent graphs and how it shifts and changes and shrinks and stretches with the parabolas? Okay. The parent graph, the parent graph for this is 1/x, and so it would just be if the asymptotes were right on the axes here. Guys, I feel like I'm fighting y'all for attention. That's right. Let's do one. Oh, I told a story. We are going to do this, the first box too. Just stay with me. Which box am I in on my flow chart? Does x have an exponent top or bottom? No. Does x appear in the top and bottom? No. So I'm in the middle box, right? All right. Again. We'll do the first box next. All right. Find and graph the horizontal asymptotes. Where are my horizontal asymptotes? -5. It's the k on the end, right? That is correct. 1, 2, 3, 4, 5.
So if this happened, we don't need
The vertical asymptote is 0.
The vertical asymptote set the denominator equal to 0 and solve. It's already solved. So I'm good to go with just placing my vertical asymptote here. Now I need my t-chart. And I am going to use which points? Which x's do I need? Uh-huh. Yep. Yes. Okay. Plug it in and see what you get. Make sure you can get it. Mark, set, go.
Wait, hang on.
Yeah, wait.
I did it right.
What was that? Profanity?
Notice what happens if I do put where the asymptote is.
Oh, that's why it says error?
Because there's an asymptote. It's undefined there. It can't be there. Make sure your t-chart matches mine. I definitely don't have enough room for these points. -2, this is 5, 6, 7, 8, 9, 10, 11, 12, 13. Guys. Oh my goodness. This one's really stretched out, isn't it? 1, 3, and 2, -1. Remember, it's got to hug the asymptote from both directions. All right. Domain and range. Okay. Domain. What is the domain here? That's right.
Wait, is it always to be negative? Just like with the things in between?
Yes. How about range? Now, tomorrow, no. Tomorrow it'll be a little different. All right, uno más. That means one more.
Oh, and then we do homework.
This is my third. Oh my god.
You're doing the other one.
What's different?
They have the X in the top and
It's
bottom.
got X in the top and the bottom. Little bit different here, okay? The graph's gonna look the same, but my steps in finding everything is a little bit different. All right, so I'm still in no, there's no exponent on X, but when I say, does X appear in the top and bottom, then I have to say yes. Yes, it does appear in the top and the bottom. So I am now in rectangle number 1.
I didn't get the rest of it.
Well, too slow to that.
All right, let's walk slowly through the steps. Okay, Ricky Bobby, slow down. All right, step 1, find and graph the horizontal asymptotes. Same step, little bit different. The horizontal asymptote this time is a ratio of the leading coefficient of the top divided by the leading coefficient of the bottom.
That's 2x.
It's just 2. This is 1, and 2 divided by 1 is
I got it. I realized.
2. This is the only different part here, y'all. All right, y equals 2.
And it's the same thing.
My vertical asymptote is the same. Set the bottom equal to 0 and solve. I always have to do that because I always have to check to see where it would be undefined. So if x minus 3 is 0, that means x is because I don't have enough room. Well, we'll make it work.
Wait, so you did 2 to the right, 2 to the left, and vertical asymptote?
Absolutely. So what do I need? What x's do I need? I need 1 and 2, 4 and 5. Be careful as you input this on your calculator because you have a fraction with multiple parts in the top as well as multiple parts in the bottom.
And then in the first box, is that the same thing that you did for 0? So you need double parentheses at the beginning?
This one you could just do, since there's nothing after the parentheses, after the fraction, bless you, you could just do parentheses around the top and the bottom, but I'm in the habit of putting my whole fraction in parentheses as well, so it's up to you. All right, I hope you're inputting as I'm inputting.
I have already done. Ella, I don't care.
Well,
I care.
my competitive nature begs to differ. Oh, why is it?
Oh, no.
Mine?
Oh, I see it.
My little graph's not considered.
Oh, this doesn't not make sense.
1, 2, 4, and 5. Oh, goodness. -1.5. -5. 9 and 5.5. Yes.
Why is there a comma button on that?
Sometimes you use that whenever you're inputting things, calculating. A lot of times with statistics with lists and variance and things like that. All right, I'm going to plot 1. You don't want me to plot yet?
Because I'm still on the top.
It's always going to be 2 to the left and 2 to the right. It's not really
Okay. 2, -5, 4, pretend like that's 9, 5, 5.5. How about the domain? Where are we messing up? What's going on?
This is going too quick.
Okay, I'm sorry. I'll stop. Let me pause. So the domain here, negative infinity up to the asymptote. Somebody asked, is it always the asymptote for these? Yes. The domain is always going from negative infinity to the vertical asymptote, and it's leaving out that vertical asymptote. How about the range? This one is the horizontal asymptote. Okay. It's telling me what x cannot be, and it's telling me what y cannot be, my asymptotes. So y is dealing with range, and x is dealing with domain. That's why it restricts both. Questions? We good?